Hi everyone, thanks for watching this webinar and signing up. It's great to have you along watching and learning a bit of new things from us. So today's webinar we'll be talking about KPIs and the presenter will be Neil. So this particular topic is very important for smelters when they're running because we want to ensure that they're under the set points and achieving what we need to achieve, and KPIs help us get there. So this particular webinar you won't be able to raise your hand or talk through the webinar. This is to avoid distractions. So instead, please put your questions into the Q&A box on the side of your computer and we'll answer them live as we go to stop distracting Neil as he talks. So thanks heaps for watching, and I look forward to talking to you more at the end. So over to you, Neil. Thanks.
Thanks, Stuart, for the introduction. So as mentioned, today's topic is selecting smelting KPIs for operational excellence. Before we delve into the agenda, let's first talk a bit about Glencore technology to give you an overview. So we've been successfully marketing technology in the metals and mineral processing industry for almost 40 years. We have about 140 employees and contractors. We have 6 offices globally to serve our clients, with a head office in Brisbane in Australia. And we have 5 main technology suites, which are the ISA Mill, the Jameson Cell, the Albion Process, the ISA Smelt, and the ISA Kid. Today's webinar, Smelting KPIs, forms part of the ISA Smelt technology group. So the agenda for today, we'll delve straight back into basics and defining what is a KPI, why should you have KPIs, how do you select these KPIs, where do you start, how to calculate these KPIs, providing feedback on these KPIs, which I think is probably one of the most important and overlooked parameters. We'll give you an example of KPIs in the ISA Smelt furnace, and we'll be giving you some recommendations and some potential pitfalls, or rather, where you've seen clients use KPIs suboptimally or at sometimes even incorrectly. And we'll also be answering some questions at the end. You might see the picture here on my right-hand side. This is a picture of an ISA Smelt shell for a furnace in Europe, which will start up at the end of the year. So we're very excited in that project. All right, so back to basics. Defining what does KPI stand for. So let's break it down. KPI is Key Performance Indicator. So let's break the words down. Key, it means not everything in the plant. Essentially, it's the key parameters with which your plant cannot run without or run suboptimally with, if they are not in specification. Performance is a certain area that is measured, be it process, safety, or cost. And then the word indicator, which to me is probably the most important word in this. An indicator is it's indicative of good or bad performance, but it's not an exact or direct measure, and that is very important. So to illustrate this, we'll give you an example where steady feed grade is an indicator of steady mat grade. But obviously, most of you know that you can't have a steady mat grade just with a homogeneous or steady feed. There are many other parameters which can also influence it, where steady feed grade is just one indicator. So why should you have KPIs? There are certain indicators or data in the plant that give a good indication of the plant operation. However, this requires an in-depth understanding of the plant. For example, experienced metallurgists can sort of come into the plant in the morning, look at a few data points, look at a few trends, and they're able to tell you, oh, the plant's running well, we need to look at this, we need to look at that. And basically, that takes a lot of experience, and KPIs can be used as a way to standardize this experience to make sure that everyone is aware of all these KPIs so that the furnace can be run optimally at all times. These days, your DCS systems probably have 100, 200, and maybe even 1,000 data points all reporting to your central database, and you can't possibly use them all the time. So you need to prioritize the most important or the key parameters, and if they're in specification first, you can look at the rest. KPIs also drive accountability. What I mean by that is numbers are hard to argue with, and it's easy for people to understand. KPIs remove the ambiguity because it's a data-driven approach, which means it's not based on perception, but it's based on an actual number. So, for example, your tapping floor operator might think that the slag is too viscous, but if he's just basing that on his perception rather than some number, the metallurgist will struggle to sort of help or try to solve the issue. But instead, the metallurgist and the tapping floor operator might refer to the tapping time in the ISA Smelt, where if the tapping time is too high, it probably means the slag is too viscous, and the metallurgist has some work to do. KPIs can also be used to sort of drive a data-driven approach to engage your stakeholders. For example, these days smelters can run quite lean crews, especially sometimes on maintenance. And as you know, things keep on sort of breaking in the plant from time to time. So basically having KPIs can help you to troubleshoot these issues optimally. For example, if the metallurgist has shown that, all my KPIs are green, or green meaning in spec, but there's this one KPI, which is my off-gas sensor gas concentration, that's in red. So either it could be a process issue, but it can also help you to sort of talk to your maintenance teams to say, guys, we need to go and try fix this issue because everything else is in spec. So it helps you to solve the problem more efficiently. So selecting KPIs. Well, before we select them, we thought to give you some characteristics of what are some good KPIs. So good KPIs are understood by everyone. That's from your tapping floor operator to your general manager in the plant. Targets are stretched but still achievable. This is really important. So for example, if you have a KPI that the target is 5 and it's normally the range is from 3 to 6, there's no point in having the KPI or the upper and lower control limit from 0 to 10. Why is that? Well, that's because your KPI will always be in specification. And that means that if it's always green, people will start not caring about your KPI and basically it'll become meaningless. It's also good if your targets are stretched, as that drives innovation and it drives operational excellence. For example, let's say you've narrowed down your lower and upper control limit, and then in a few months' time, you might be able to narrow it down further and further. And that can increase productivity and allow you to get more from your smelter operation. Your KPI should be easily calculated and confirmed as correct. Sort of a weird example, you shouldn't be calculating a KPI on a Tuesday different to a Thursday, and you shouldn't sort of 1 week decide this is how you calculate it, and the next week this is how you calculate it. It should be consistent. Consistency drives people to sort of buy into your ideas. It's also important that KPIs drive the right behavior. So probably a bad KPI, but just to illustrate the example, if you tell your tapping floor operators, I need 12 samples in your 12-hour shift, that's very badly defined, because then they might take 5 SIAC samples in the first hour, 4 in the next hour, and the rest in the last hour. Your KPI should rather be take 1 SIAC sample every hour, and that will enhance, or that will promote driving the right behavior. It's also useful if several items are captured in one KPI, especially at higher levels in your organization. So basically your tapping time can be used to infer whether you have temperature fluctuations, if your temperature in your furnace is too hot or too cold, and it can also promote some viscosity and perhaps even some SIAC chemistry, it can give you some insight into it and what might need to change. It's important that your KPIs can be filtered, delayed, and sorted by crew or area or job role. And that is to be able to give specific feedback to your crews. I highlighted this in blue because I think it's very important. It's crucial that the KPIs are within the person's control or influence. So again, tapping floor operator, there's no point in having his KPI as the amount of acid that your acid plant produces, because he has no direct influence over that. And that if that is his KPI, he will basically not have the buy-in, and he will sort of feel that there's no point in having this KPI, and he might not do the job as good as he can. So where do you start? Well, it's important to have a solid understanding of the plant or process, and that means by understanding the inferred meaning around instrumentation or data. And I think, as sort of an artificial intelligence and these large sort of language models come into it, that's very important. I heard a story of a consulting firm coming in and basically trying to build this AI model to sort of highlight what KPIs should this smelter and acid plant run at to sort of run optimally. And on the first pass, this AI model came up with, well, if the plant produces more acid, the furnace will run better. Well, obviously, most of you know that that doesn't make any sense. If your furnace runs well, you produce more sulfuric acid. So, that's an obvious example, but it's just to illustrate that you need a solid understanding, and you can't make relationships without understanding what actually is behind these KPIs. Understand your instrument limitations and their reliability. So don't choose an instrument that's prone to failure. So for example, if you choose an instrument or temperature thermocouple, that's your KPI. On a Monday, it's green, it's in specification. On a Tuesday, that instrument's failed, so it gets fixed. And on a Wednesday, it's red, it's out of spec. Then it's sort of like, well, is the instrument fixed? Is it working? Is it not? And you immediately lose credibility in your KPIs if you do that. It's also important to understand the measuring frequency of your instruments. To give an example, you can think of your off-gas instrumentation. So basically, some of these instruments would take an online sample of your gas and then give you a result after a few minutes. So if that's the case, there's no point in measuring this instrument every 1 minute or 2 minutes of your KPIs, because it won't change. So understand your frequency measurement. It's also important to understand your range and sensitivity of the instruments, and this might lead you to think that, maybe I need a new sensor here or a sensor with a bigger range. So for example, there's no point in having your KPI at the upper or lower limit of your instrument range, because then it could flatline and then you think, oh great, I'm in spec, I'm out of spec, but actually just out of range of the instrument. It's also quite useful to have second instruments to confirm your readings. So for example, in the ISA smelt, you could use your tip pressure and your lance carriage vibration to indicate the lance immersion. So as an example, if your lance is deep in the bath, your tip pressure is high and your lance carriage is vibrating, it probably indicates your lance is too deep in the bath. But let's go and say your tip pressure is very high, but your lance carriage vibration sensor is not showing any vibration, and physically you can't see any vibration. That probably means there's something wrong with your tip pressure. And by doing that, you build more credibility in your KPIs, because people will be like, yeah, but I know that the lance isn't, I know the tip pressure is broken, and this is a way for you to verify that and show it in your KPIs. It's also important to have minimal reliance on human observation or logging, so that just makes the process more open and fair and transparent to all individuals involved. So calculating your KPIs. So your larger organizations might have access to sort of a Viva Pi system or interface, which is very useful, which can calculate your KPIs automatically. I've also seen Microsoft Power BI being used as sort of the graphical user interface that looks quite nicely. So you must use a Pi system or similar, but essentially you load up this dashboard in the morning and it automatically calculates, and you can have a very nice set of looking KPIs. For smaller organizations that don't have access to the Pi, you might have to use your DCS, grab some Excel graphs or something similar to that, but that can also work quite nicely. As a side note, it's probably sort of mirrors or sort of goes into more daily checklists, but you can also use your site procurements register, and that's basically if you're suddenly using more thermocouples or more Cermits or more oxylances, it could indicate there's something wrong in your process, and just having that data can tell you more quite effectively. And just mention again, it's important to understand your data and how it is collected. Use filtering to remove unwanted data. You typically want to have your KPIs only running or showing or calculating when your furnace is smelting or when you're operating. That's because the variables are in a different state when you're smelting versus when you're not. So to do that, you can filter for example, when the lance height is below X millimeters, or for example, if the lance is oxygen enrichment running through it, just to mention a few examples. So selecting time periods that match up with your crew shifts. It's easy to collate by crew and review the last week, month, or year's performance. And you can also see how different crews operate. So I've had past experience with this, where we had 4 shifts and we basically heat mapped sort of the way they run their different parameters. So be it sort of temperature, how they control the chemistry in the furnace, we sort of mapped it on a heat map, and you could see differences between the shifts. And that's sort of, at the end of the day, the operators are running the same furnace, so ideally it should all be, heat map should be fairly concentrated. But we saw some differences, and we started talking about it, and we sort of understood, this crew's doing that, and that crew's doing this, and this one's struggling with that topic, and that one's struggling with that. And sort of having that data open and allowing people to talk about it actually enhanced the smelter operation quite a bit, and we actually solved some issues and increased our productivity. So I guess now you know how to calculate your KPIs. So how do you set these achievable targets? In a new furnace, you might be prone to use your design documentation to set your limits and things, and that can work in a new furnace. But if you've been operating your furnace for a while, it makes sense to use your historical data to help you to determine where your lower and upper control limits should be. And I guess, how do you do that? You would pick the operating times where you've been running optimally in the plant or in a certain area of the plant, and you know that, cool, that's the limit of this KPI or that variable, and that's when the furnace is running the best way possible. So displaying the KPIs, I prefer a graph and table format as useful display methods. The KPIs should report to a central dashboard, displaying their values and their targets. Color coding is recommended. That just makes it easy to see, this is in spec, that's out of spec. It makes it a bit more user friendly. And I prefer, and it's up to your organization, but if you can go to your dashboard app in a morning meeting, it sort of can be used to drive actions in your meeting. So for the table format, you have a table of all your KPIs with links to your graphs. I like the table format because if they're color coded, it allows you the ability to easily sort of see, this is in spec, that's out of spec. It just sort of makes it easy for the eye to look at. And sort of how you color code it is open to the organization. But for example, if your KPI is red, it means your KPI is out of limits and you need to address that as soon as possible. Yellow could mean your KPI is deviating close to its limits or out of its limits. You need to investigate that after you've solved your red KPIs. It could be a leading indicator of something. And your green KPIs, they're in range and typically no real action required. I mentioned here that I've seen some organizations not use the yellow or the amber or the warning in their KPIs. They sort of believe that things are either right or wrong or red and green. For me, that's why I put the traffic light example there. If you imagine you're driving on a highway, on a road, it's green and suddenly the traffic light hits red, you have to stop, it's panic, everything like that. It's not well planned. That creates some chaos, and I think the same can be relevant to your KPIs. You want a warning to know that, I've had these red KPIs, I'll solve them first, but these are next, and if I don't solve them now, they will become red. So it promotes you not solving anything and then suddenly having to solve the issue. So this table gives you an example of the KPI output. So just to explain this table, I've got my parameter, UOM is my unit of measure, LCL, lower control limit, UCL, upper control limit, actions and comments, which I'll get to, the target, and then the daily KPI average, the weekly and the monthly. So daily, typically 24 hours. You can also do a shiftly one, weekly, every 7 days, and monthly. For me, I prefer a rolling 30 days. Other organizations, especially for more production-geared KPIs, might use like a month to date. So to get into the KPIs, the reason I like the daily, weekly, and the monthly is because it can sort of show some trends in a table format, which can be quite useful. So as an example here, the off-gas pressure, negative 60 pascals, negative 65 for the week, and negative 65 for the day, that's okay. But if it was negative 60, negative 70, and negative 80 on your daily, that indicates, I might be having a blockage in my off-gas smelter. And you can do that just by looking at this table, which is quite user-friendly. You also see that I used bath temperature and time above 1230, and I just told you to combine KPIs into one where possible. So I did that on purpose just to illustrate there's different ways to sort of display your KPIs. The better one to use here is your tapping temperature set point in order, and your tapping time would be a better KPI to use. So for example, you can see your bath temperature, it's 1233 for the daily average, so it's out of range. So on the table, you might instinctively think, the furnace ran too hot for the whole day. So ideally, what you want to do is you want to click on your 1233, and it opens up a graph for you, which shows your daily average temperature, your lower control limit, and your upper control limit over the 24 hours. And this sort of gives you some more information. You can see that, the day shift, ran the furnace quite nicely, and there was an issue during night shift. So it's not to blame anyone, but it's to be able to solve the problem. So what changed from the day shift to the night shift that now suddenly we have some temperature issues? Giving KPI feedback. Before you can give feedback, it's important that people actually understand what does each KPI mean and why do they need to follow this KPI. It's important to give regular feedback and consistent feedback as well. So it depends on the organization, but email your daily KPIs to your stakeholders with your comments and actions required. That sort of shows that you're monitoring these KPIs and also you're being consistent about it, and you promote the openness and the buy-in into these KPIs. And also people respond to consistent dialogue and monitoring. It's important to make sure that your KPIs are accurate and reliable. Try not to make a mistake in your calculation of your KPIs, or be open to it if you have and solve the issue. It's also important to check your log sheets for operator comments and take these into consideration along with your KPIs. There might be a reason why something is deviating. As mentioned previously, but use two sources of instrumentation data where possible to verify your KPIs to make sure that there hasn't just been an instrument failure. Another example would just be sort of an average bin level in your feed preparation plant versus a crude mass balance of how much you ran for the day. That can give you an idea of, I'm sort of in the ballpark. So this table gives you an example of sort of KPI escalation in the Isosmelt furnace using the temperature set point. So for example here, you've got your person, so control room operator down to your technical manager. You've got your KPI, your controllables, and your indications or indicators. So for example, your CRO, well, his KPI is the instantaneous bath temperature tapping. Bath temperature set point should be in auto. His controllables are basically just to put this in auto. And some organizations might allow him to change the enrichment, oxygen enrichment as well. And his indicators, even if sort of he's done all of this, is that, well, the tapping set point is not working, or there's some charge or feed mix issues, or some bin delivery issues as well, sort of a bin holding up or something similar. So your shift coach, he's sort of responsible for his CRO's actions. So he'd be monitored the average temperature of his crew for the day or for the week. His controllables are basically to get his mixing plant operators to go and check, are there any bin hang-ups, is there some contamination, this feed looks a bit different to that one. And he'd raise in the shift notes, and then the metallurgist would also assist in solving this. So the Mets would basically look at the daily and average temperature. Their controllables could be the charge of the feed mix, and again, it's very open to the organization and what you're smelting. So for example, some organizations change their feed quite frequently. So if the slag is too viscous, or there's a reason the control operator might be running the furnace a bit hotter because your percentage solids in your charge might have changed, and we might have to change the chemistry, change the fluxing, or depending on the organization, maybe change your temperature target slightly. The superintendent, he monitors his crews and his crew's temperatures and basically what they do for the week and the month. His controls are sort of talking to the operators, well, how can we do this better? How can we improve? And he'd raise it with the technical team. And I put this here as sort of the technical manager. He might be looking at your refractory long-term trends. So, if suddenly the refractory temperatures are going higher, indicates, we might have some issues. We might have to sort of plan for the rubric's in line. And this is just sort of as a learning, not to blame anyone, but he can go back and see, well, the furnace was running too hot for a month here or 3 weeks here, and that's probably why, or could be an indicator, or could be another reason why we need to have a rubric maybe sooner than anticipated. So recommendations and potential pitfalls. The KPI should be visible or accessible in a view mode to all stakeholders. This just drives the openness of the whole process. You have to reinforce that it's an indicator only. The KPIs aren't going to tell you how to run the furnace. They're just going to indicate to you that, something is wrong here, something is deviating. It's important to have a logbook of the reason behind every KPI, and that's so everyone understands the KPI and why it is chosen. Especially in organizations that have high turnover, it's important that every new person coming in sort of understands why is this KPI here. And again, I'm giving some very obvious and maybe some strange examples, but for example, if someone's KPI is to monitor the cooling water flows and the temperatures, and well, they see the KPIs are in spec, the thermocouple is reading 25 degrees, it's okay, but the pipes feel quite hot or something, there needs to be some understanding that, there's probably an issue, this instrument might just be broken. So, don't just blindly follow your KPIs, make sure you understand why you have that KPI. We talked about it a bit, but aim to incorporate your KPIs into each other. Don't add another KPI to your list just because something happened before. Only add something if it adds value, and maybe even have a sign-off procedure to be like, we want to add this KPI and these are the reasons for it. Keep a record of why each KPI was chosen. As mentioned, this just sort of, and why the chosen range is there. This is so that if a new person comes in, they know exactly why it was chosen. Or KPI could have been selected 5 years ago, and now it's no longer even an issue. So, but then you think, but why is it even there? And there might be a very good reason for it. So, just be aware of that. Organization smelt performance can change from time to time. So basically, you could be running some nice concentrates, then you get into some more complex concentrates, you become a toll smelter. So be open to your KPIs and be open to changing them from time to time if you need to. It's important to periodically check your raw data of your KPIs, especially those ones that are in spec most of the time. Just make sure nothing is flatlined. Look at your graphs, look at the raw data. Just make sure everything's still reporting to your central database, just to negate any mistakes. External or non-process KPIs are quite useful. This is more, it delves into what a daily metallurgical checklist is. But just sort of monitor some orders from stores. If you're suddenly ordering more oxylancers or some more bath cermets, there could be an issue, and that just can tell you more about your process. So in summary, we defined what is a KPI, why do you need KPIs? How do you select these KPIs? We gave an example of a KPI approach, gave some recommendations, and we'll answer some questions at the end. Thank you.
Thanks, Neil. That was a great webinar. I learned some new things and hope others did too. Good refresher as well, because I haven't been on a running smelter for a couple of years, 24/7. So some of these things is always have a good refresher on. So we've had a few questions from the audience on some things, which we'll have a bit of time to go through. So we've only got time to sort of go through 3, but we'll go through those ones. So the first one is a bit about KPIs and how organisations choose them. So the specific question is, so some organisations may choose to have many KPIs which blur the line between KPIs and checklists, and how is this managed? So I guess we can relate this to smelters. I've been to one where the manager decided every single measured thing became a KPI, and then everyone was running around trying to check off all the little KPIs that was now there. So in these situations, how is this all managed and blur these lines, and how we fix this?
That's a good question, I guess. And like you said, yes, some organizations, especially if you're under like high production pressures, you don't want this furnace to stop. And you basically have your major KPIs, and then, one thing happened and suddenly, we make that a KPI. Have a downtime event because of this, you make that a KPI. And essentially then you have major KPIs and minor KPIs, and they all come together. And essentially, it might work for the first week or the first month, and then suddenly, instead of focusing only on your major things or prioritizing them, you start focusing on your minor KPIs. And then eventually you'll get caught out. You just can't focus on all these things at the same time. One of your major KPIs will slip, and you'll have some unplanned downtime or out-of-spec product. So how is it managed? That's a tough one. I think you need to understand what's the difference between a KPI and a checklist. So the way I see it is your KPIs are displayed to all your stakeholders every day, every morning meeting. You see them on the board. That's what we're focusing on for today. And then you have some other daily checklists which your operators and your METs would do, but you only report on them by exception. So, like your KPIs, focus on them, but people don't even worry about the checklist unless there's something wrong. Essentially, that's how I would approach it. Don't know if you have anything to add or...
No, I guess that comes through. The next question we've got that comes through is how many KPIs are enough and how many are too many? And if too many, how do you reduce them? So we say that we can deconvolute between checklists and KPIs, but even then sometimes people decide that this thing becomes a KPI and you start to get all these extra KPIs. So how do you determine what's the number of KPIs and what's suitable?
That's quite a good question. I guess to sort of know or determine how many KPIs are too many, you can't give an exact value to it, in my opinion. Depends how the smelter is operating. So, a stable furnace might have a few of those KPIs, and a furnace that's ramping up in the commissioning stages and they're trying to set their KPIs. And again, that'll be different to a furnace that's been running for a while and trying to get their steady production. So, don't want to commit to a number, but let's say maybe 10, 15 KPIs for a stable furnace, along with your sort of off-gas system, would work. So I guess how do you manage that, or how do you reduce them? Well, the obvious or the most important thing is to sort of, and we spoke about it in the webinar, is to try and merge your KPIs into one. So basically you want to almost sketch a tree and understand, I've got these 5 variables, but this variable depends on that one. And by doing that, you can sort of only have one KPI. And if that's out of spec, you can go look at these different types of things. I guess that's one option. And the other option, which is probably more difficult, is to almost sort of create some control loops for yourself. So instead of monitoring the furnace temperature and sort of the rate of sort of increase and decrease in your furnace temperature, maybe have a control loop which controls your furnace temperature. So then you're only looking at that control loop. That's, off the bat, that's probably what I would do.
I guess one of the ways that I've seen is my rough rule of thumb is you can only have as many KPIs as you have things you can control. So if you can only control 3 or 4 things in your feed blend, then you can only have 3 or 4 KPIs at the end.
Yeah.
And you can't have more, because all of a sudden you can't achieve your KPI if you've got nothing you control to achieve it.
Yeah, so exactly. And then people don't buy in after that as well. So that makes sense.
Last question. Unfortunately, running a bit out of time here. So what are some of the things you've seen work well and work not so well when giving employees KPI feedback, because we have to measure and assess adherence to KPIs and then sort of say how the plant went and then provide feedback to others and how does that all go and how do we make sure that goes well.
Yeah, I think, how do you provide feedback? I guess the most important thing is to actually just be consistent in your feedback. I think, and it's sort of every day, every week, be consistent, give your list of KPIs, tell people where they can improve, where they can't improve. And I guess an important point in that is we always talk about how can people improve, but also if the KPI has been in spec for a week or a month, actually promote that and say, this crew's doing exceptional, this KPI is always in spec. And by doing that, you also promote that people actually want to talk about the KPIs. If you're always negative and say, this KPI has been read, what are you guys doing here? That, people have this negative connotation. So I think positive reinforcement, positive feedback helps. And I guess, to get the buy-in for the KPIs, it's also important to actually, when you set these KPIs, don't come into your smelter on a Tuesday and say, right, shift A, you're following this KPI from now on, and leave the room. Go talk to them, tell them, I want to do this KPI. This is why I want to do it. What do they suggest? And if you actually start there, they might have, they feel like they're part of the decision-making process as well, and that'll just promote the buy-in. Another thing that's probably worked is if you want to make your KPIs important, you can probably get sort of the plant manager, production manager, or superintendent to sort of sign off on these KPIs, show it to the shift to be like, this is actually really important.
No? Great. I think that's about all we have time for. But thanks for presenting, Neil. Thanks for the questions. I had a good time having a chat. Hopefully everyone did as well. And so thanks for everyone who watched, and hopefully we'll see you at the next webinar.
Thank you.